Exponent rules. So here's a chart of the 5 exponent rules that we're going to be looking at here. So in the first column is the name of the rule. The middle is that definition of what it looks like in your textbook. And then on the right, I threw an example in there so you can see it in action. So the first row, 0 exponent rule, means anytime you raise something to a 0 power, it equals 1. So no matter what you raise to 0, it goes to 1. So if we raise 2x within parentheses to 0, it equals 1. Negative exponent rule means anytime you raise something to a negative number, that negative is going to flip it. So it's going to flip it like a fraction. So if it's like a whole number piece, it's going to flip to be 1 over that. If it was already a fraction that had a negative exponent, it would flip into a whole number. So top and bottom are flipping. Product rule states that if you're multiplying two terms that have the same variable base, then you're actually going to add the exponents together. So on the far right column, you can see y to the 6 times y to the 3rd. They both have a y as their base. So if you add the two exponents, you get y to the 9th. Quotient rule states that if we are dividing, similar to product rule, but we are dividing with the same base, we actually end up subtracting their exponents. So b to the 7th over b squared, they both have that b base, subtract their exponents to get b to the 5. And the last one, power rule, states that if there's an exponent outside of a parenthesis, it's actually going to get distributed to everything inside the parenthesis. So in the far right column, you can see a squared b raised to the 3rd power. That 3 is going to come in and multiply by each one of your exponents. So it's going to multiply by the 2 for the a and multiply by that 1 on the b to get a to the 6 b cubed. Now, when it comes to exponents and you're looking at new problems each time, you're going to apply these rules as needed. So there's not necessarily one rule that has to come in before the other one, but just make sure that you apply the rule all the way through. So if you're doing power rule, make sure you carry it through to everything. If you're doing product rule, make sure you're combining things with like bases. The very end of your problem, just make sure there are no negative exponents left. You should always have positive exponents for your final answer. Now we're going to try a couple here. These are 4 kind of important things to make sure you just note for these. Example 1, simplify 8x to the negative 1. And if you look real quick at example 2, just below it, it's still 8x, but it's raised to a negative 2. I put these two side by side because one has a parenthesis and one doesn't. So I want you to note that when you're looking at problems, if there's parentheses or not, because it will make a difference. Parentheses on example 1 means that negative 1 is going to go to the whole thing. So negative exponent means we're going to flip it. So currently it's like over a 1. So if we flip the whole thing, we get 1 over 8x as our final answer. All positive exponents, we're good to go. Now in number 2, there's not a parenthesis. So when you have an exponent, it is only going to apply to the thing directly in front of it. So in this case, this negative 2 only applies to the x. It doesn't reach to the 8. So in this case, our negative exponent is going to flip our x. So x is going to move to the bottom of the fraction. 8 is going to stay on top. And we're going to keep that exponent of 2 with the x. So in this case, the only thing that happened was that negative exponent just moved that x squared to the bottom. And you're all done. Example 3. You're going to see problems more like example 3 and 4, where there's maybe more than one variable, more than one thing going on. So you have to look at it and figure out of our rules, which one am I applying? So one of the things you want to look for is you want to clear out any parentheses. You want to combine with either product rule, quotient rule, and then at the end, make sure you're always checking that there's no negative exponents in there. So in this case, the only bases that match are my x's. So x to the 7 over x to the 5. So in this case, I'm going to be using quotient rule here. Since they're being divided, they're stacked on top of each other, I'm going to subtract their exponents. So 7 minus 5, I get x squared. And there's nothing to combine with the y squared, so we just keep it. So this one was using our quotient rule. Our last example, example 4, it says simplify. We've got a lot of stuff going on in parentheses, and then we have the number 3 out back. So that number 3 in the back, our exponent, this is going to be a product rule. We're going to distribute that 3 into everything inside the parentheses. Now here's where it gets tricky. It gets distributed to both of your variables with their exponents and to any constants in the front, any leading coefficients. So what that looks like, if I write out my steps here, that means 5 is going to be cubed. Then we're going to multiply the exponent for the 2 and the 3 on the x. Then we're going to multiply the exponent for the -1 and 3 on the y. So 5 cubed is 125. So that's 5 times itself 3 times. X to the 6th, y to the -3rd. Give yourself that moment to check it. We can't leave it with a negative exponent in there. So the last thing we're going to do is move that y cubed to the bottom. And that's the only thing that gets moved down because it was the only one that had a negative exponent.